Okay, we're going to look at 5.7, and that is on inverse trig functions. We are going to start with our trig function y equals cosine x. We want to find its inverse function. Now, we're sort of used to using the other notation for the function. So let me get rid of this y, and let's put in f of x there. So again, it is just a notation difference. So we are wanting to find the inverse function, f inverse of x. So let's review the things that we know about inverse functions. If we have inverse function, f of inverse function x, well, that's equal to x. The composition of a function and its inverse function equals x. To have an inverse function, f of x has to be 1 to 1. And I'm going to write that as 1 to 1. So let's remind ourselves how we determine if we have a 1-to-1 function. It has to pass the horizontal line test. So the horizontal line test is if we take a horizontal line, we pass it through our function. Well, we see that we are crossing our cosine function at 3 points. So the cosine x function does not pass the horizontal line test, and it is not 1 to 1. It's looking like we can just throw this section away and not find the inverse function. But wait. We are actually going to restrict the domain of the cosine function so that it is 1 to 1. So let's get rid of this part of the function, and let's get rid of this part of the function. In other words, we restrict the domain. We restrict the domain for x values from 0 to pi. Now, if we apply the horizontal line test, we cross one single time, and f of x equals cosine x is 1 to 1. So with this restricted domain, f of x equal to cosine x, with that domain of x values between 0 and pi, it has an inverse function. So y equal to cosine inverse of x means that x equal to cosine y for y values that are in between or equal to 0. So notice that y is an angle measure. The result of an inverse function, the function value for an inverse function, is going to be an angle measure. So let's evaluate an inverse function, and we want cosine inverse of -1/2. So notice the input is a value, not an angle. The result that we are going to get is an angle. So what we plug in here will be an angle measure. And what we want is the angle measure y such that the cosine of y is equal to -1/2. Now, in terms of the unit circle, because we are limited for values of the angle measure, we are looking for 0 to pi. And because we're looking for cosine, we're going to look for the angle that has the x-coordinate that is equal to -1/2. All right, so as we go through, we come here to 2 pi over 3. The x-coordinate is a -1/2, so that tells us that the cosine of -2 pi over 3 is equal to -1/2. So we could say that cosine 2 pi over 3 is -1/2. So to evaluate cosine inverse of -1/2, that is this angle 2 pi over 3. Okay, let's look at another one. Let's look at cosine inverse of square root 3 over 2. So we're just limiting our angles to 0 to 2 pi, and what we're looking for is the angle that has the cosine of square root 3 over 2. So in the unit circle, that's going to be the angle that has a cosine value or an x value in its associated point equal to square root 3 over 2. All right, so as we look at our points, we actually come to here, pi over 6 has square root 3 over 2, positive square root 3 over 2. So the angle that has cosine of square root 3 over 2, the answer to that is pi over 6. So that means that cosine inverse of square root 3 over 2 is equal to pi over 6. Another way to express the inverse cosine function is y equal to arc cosine x. So that's equivalent to y equals this notation that we've been using with the little superscript of -1. Both of those notations express the inverse cosine of x. So let's use that notation and evaluate y equals arc cosine of, and we will put in a cosine value of 1. So we're asking the question, what angle has cosine equal to 1? We can look at our unit circle, and we're just looking at these values of angles from 0 to pi. Cosine actually is going to be 1 when we have an angle measure of 0. The answer to that is angle measure of 0. Y equal to arc cosine of 1 is equal to 0. And that is because the cosine of angle measure of 0 is equal to 1. All right, let's look at this one. Y equals arc cosine of sine of pi. So we have like a composition of functions here. We want to evaluate sine of pi first and then plug that value into that inverse cosine function. So sine of pi, we're going to look at our unit circle. Let's go around to pi. The sine is going to be the y-coordinate of 0. So we get the sine of pi is 0. Now we can evaluate this arc cosine function, replacing the sine of pi with what it's equal to, which is 0. So now we want to ask the question, what angle has cosine of 0? Looking at our unit circle, we want to go around, we want to find the angle that has that x-coordinate equal to 0 because that's the cosine. Well, that is pi over 2. Y equal to arc cosine of 0 is equal to pi over 2. And that is because the cosine of pi over 2 is equal to 0. Now let's look at the inverse sine function. So here's a graph of the sine function, and we can see that just like the cosine function, it is not one-to-one. We've got a horizontal line crossing at multiple places. So we need to restrict the domain. So we will restrict the domain to angle measures of negative pi over 2 to positive pi over 2. Now it will pass the horizontal line test, be one-to-one, and have an inverse. So the inverse sine function, y equals sine inverse of x, means that sine of y equals x for y values that are negative pi over 2 to positive pi over 2. We can also use the notation y equals arc sine of x to indicate the inverse sine function. All right, we're ready to evaluate some inverse sine functions. Let's evaluate sine inverse of 1/2. Keeping in mind that we are limited to the angle measures from negative pi over 2 to positive pi over 2. So we are going to ask ourselves the question, what angle has a sine value of 1/2. So we look at our unit circle and we want positive 1/2, and we are going to look for the y-coordinate that has a positive 1/2 because that is what gives us the sine function value. So pi over 6 has the y-coordinate on the unit circle of 1/2. So that means that that is the angle measure that we are looking for, pi over 6. So sine inverse of 1/2 is equal to pi over 6, and that is because the sine of pi over 6 is equal to 1/2. Let's find the arcsine of -1. So that means that we are asking the question, what angle has sine of -1? We look at our unit circle from negative pi over 2 to positive pi over 2, and we're looking for the y-coordinate to be -1. Well, that is right here at negative pi over 2. We have y-coordinate of -1, so the sine value is -1. So the answer to that is negative pi over 2. So arcsine of -1 is negative pi over 2, and that is because the sine of negative pi over 2 is equal to -1. All right, let's look for the sine inverse of square root 3 over 2. And that is going to be asking the question, what angle has square root 3 over 2 as its sine value? All right, so let's look at our angles here, and we go to pi over 3, and that gives us the y-coordinate of square root 3 over 2, which is the sine value. So the angle that we're looking for is pi over 3. So sine inverse of square root 3 over 2 is pi over 3. That is because the sine of pi over 3 is equal to square root 3 over 2. Now let's find arcsine of cosine of negative pi over 4. So first thing we want to do is evaluate cosine of negative pi over 4. So this time we look for that angle and pick out the x-coordinate from the unit circle. So here's negative pi over 4. Cosine is square root 2 over 2. So cosine negative pi over 4 is square root 2 over 2. So we are looking for arcsine of square root 2 over 2. That means we're asking the question, what angle has sine of square root 2 over 2? Looking at our unit circle, all right, we get to pi over 4. That has square root 2 over 2 as its y value, pi over 4. So arcsine of cosine of negative pi over 4 is equal to positive pi over 4. Let's review the ranges of the inverse trig functions that we have looked at. Y equals sine inverse of x, and its range is limited to negative pi over 2 to positive pi over 2. One way to think of that is that its resulting values are going to be from quadrant 1 and quadrant 4. We've also looked at y equals cosine inverse of x. It is limited to, the range is limited to angles that are between 0 and pi. And a way to think about that is quadrant 1 and quadrant 2. Now there are 4 other trig functions that we haven't looked at as far as their inverse functions go. They work similar to sine and cosine, where we're going to have a limit on the range of the inverse function. So the ones that have the same limit on the range as the inverse sine are tangent and cosecant. And remember, cosecant is the reciprocal function for sine. Those 3 inverse functions have a limit on the range, what the resulting function value is, from negative pi over 2 to positive pi over 2. Now the inverse functions have the same range as cosine inverse are y equal to cotangent inverse and y equal to secant inverse, where remember secant is the reciprocal function for cosine.